Assalamualaikum. Today we're going to present about application of differentiation. First, we go to the introduction of differentiation. The process of finding derivative of a function is called differentiation in calculus. Derivative is the rate of change of a function with respect to another quantity. The law of differential calculus were laid by Sir Isaac Newton. The principle of limits and derivatives are used in many disciplines of science. Differentiation and integration from the major concept of calculus. What is differentiation? Differentiation means the rate of change of one quantity with respect to another. The speed is calculated as the rate of change of distance with respect to time. The speed at each instant is not the same as the average calculated. Speed is the same as the slope, which is nothing but the instantaneous rate of change of the distance over a period of time.
Moving on, we are going to talk about the application of differentiation. The concept of derivatives has been used in small scale or large scale. The concept of derivative can be used to find different types of problems. In this case, we highlight the use of derivative concept to find the maximum and minimum value of the given function. We learn to find the maximum and minimum values of functions, and with a specific set of skills, it will allow us to solve many kinds of problems in which we need to find the largest or smallest value in a real-world situation. For example, we know that the information about gradient or slope can be derived from the derivative of a function. We try to find the point which has zero gradients, then locate the maximum or minimum value near it. Also, the concept of derivative can be used to find the profit and loss business using graphs, to check the temperature variation, to determine the speed or distance covered such as miles per hour or kilometers per hour.
Problem statement. The diagram shows a jogging track in the shape of a rectangle with a semicircle on both ends. The perimeter of the track is 400 meters. Let x and y be the length and width of the rectangle. The questions are: 1a. Obtain an expression for y in terms of x. 1b. Show that the area of the track is given by a equals to 200x minus pi x squared over 4. 1c. Hence, determine the value of x so that the area of the track is maximized. For the problem solution for question 1a, we can conclude that the total perimeter of the track is 400 meters. Hence, 400 meters equals to the length of the width of the rectangle, that is y. Hence, we got 2 width, that is 2y, plus 2 semicircles. 2 semicircles is equal to a circle. The radius of the semicircle is x over 2. So the total equation is 400 equals to 2 times y plus 2 pi times x over 2. We can simplify it by 400 equals to 2y plus pi x. Hence, we express the y in terms of x. We move the 400 to the left, to the right. Then that we move the pi x to the left. So we could get 2y equals 400 minus pi x. And then we let the y is alone and move the number 2 from a multiple to divided. We could get y equals to 400 minus pi x over 2. Next question, 1b. A equals to, the area of the total jogging track is a rectangle plus 2 semicircles. Hence, 2 semicircles is equal to a circle. Hence, the total equation is y times x plus pi times x over 2 to the power of 2. Hence, we simplify it. A equals to yx plus pi x squared over 4. We substitute the y from the 1a. We can get a equals to 400 minus pi x over 2 times x plus pi x squared over 4. Then we can get a equals to 200x minus pi x squared over 2 plus pi x squared over 4. To get the same denominator for the both fractions, we must multiply by 2 on the left fraction. Hence, we can get a equals to 200x times 8 minus 2 times pi x squared over 2 plus pi x squared over 4. Then we can get a equals to 200x minus 2 pi x squared over 4 plus pi x squared over 4. Hence, the final answer is a equals to 200x minus pi x squared over 4. Moving on to the next question. To determine the maximum area of the jogging track, we must differentiate the equation from the answer on 1b. Hence, the final differentiate of the equation is 200 minus 8 pi x over 16. To determine the 8 pi x squared over 4, we must differentiate using the quotient rule. Hence, we can get 8 pi x over 16. Then we let 0 equals to dA over dx. Hence, 0 is equal to 200 minus pi x over 2. And then we move the 200 to the left. We can get negative 200 equals to negative pi x over 2. We move the denominator from the pi x to the left. That will be a multiply, that we can get negative 400 equals negative pi x. Hence, we express x in terms of pi. X equals to 400 over pi. Hence, the answer is x equals 400 over pi, or 127.324 meters. Hence, that's the final answer.
As for the conclusion, application of differentiation is an important concept for solving maximum and minimum problems. Based on the problem statement, we are given clues on the figure stated in the question. The figure is used within the problem solution. Based on the problem solution for the first question, we are given the perimeter of the jogging track, the figure stated in the question, 400 meters. Due to this, we use the perimeter formula to express y in terms of x. For the second question, we are given the area of the track by a equals to 200x minus pi multiplied by x with the power of 2 divided by 4. So we compare the area given by finding the area of the track. To find the area of the track, we use rectangular area, which is y multiplied by x, total it with semicircle area, which is pi multiplied by x divided by 2 with the power of 2. The y for rectangular area can be replaced with the answer from the first question. Lastly, for the third question, we must first find the derivative to solve the question. Then let the derivative equal to 0 and find the value of the variables. After that, find the second derivative. If the second derivative is much more than 0, it is a minimum value, while if the second derivative is much less than 0, it is a maximum value.